Global cement production has increased almost threefold from 1.4 billion tons in 1995 to 4.1 billion tons in 2014 and remained more or less stagnant since then. China is the largest cement producer. India is a distant second with a share of 8% as of 2020. In 2019-20, India's overall production stood at 334 million tons with a capacity of 537 million tons. But cement, on which real estate and infrastructure is dependent, is a major contributor to greenhouse gas emissions. In 2016, the cement sector of India contributed around 160 million tons or 5.63% of country's total emissions. CSE estimates showed that top 5 cement companies in terms of production contributed almost 51% of the CO2 emissions in India as of 2019-20. CSE believes this is a huge opportunity for reducing emissions from the sector. Hi, I am Parth Kumar, working as a program manager with the industry team at the Center for Science and Environment. More than 99% of the greenhouse gases emitted from the manufacturing process is CO2. Limestone has been the main raw material for manufacturing cement, and its conversion process is responsible for more than half the share of CO2 emissions during manufacturing. The combustion of fossil fuels such as coal and petcoke to convert limestone into lime is responsible for 40% of the gases emitted. The rest 10% of emissions is through electricity usage from the grid or captive power plant. Different types of cement are produced in India based on the amount and type of alternate raw materials replacing limestone during manufacturing. Ordinary Portland cement or OPC, Portland Pozzolana cement or PPC, Portland slag cement or PSC, and composite cement or CC. Out of these, 65% production is of PPC. The BIS has made standards with respect to the composition and usage of these 4 types of cement. Here you can see the average CO2 emissions emitted per ton of cement from each of these 4 types of cement. CSE has projected 4 CO2 emission scenarios for the year 2030. First is the business as usual or the BAU scenario. This is based on emission factors of 2019-20 and estimated production of cement in 2030. As per this scenario, CO2 emissions from the sector are projected to grow almost twice within this period. The second scenario is the low carbon growth scenario. This scenario is based on past emission reduction intensity achieved between 1996 and 2017 and the estimated production of cement in 2030. As per this scenario, the CO2 emissions will increase 1.6 times and show a reduction of 18% from the BAU scenario. The third scenario is the improved low carbon scenario. This scenario is based on the voluntary emission reduction targets set by large cement companies. As per this scenario, the CO2 emissions will increase 1.5 times and show a reduction of 23% from the BAU scenario. The fourth scenario is the accelerated low carbon scenario. This has been proposed by CSE for 2030, but before we delve into this scenario, let's discuss the available pathways for the sector's decarbonization. There are some prominent options being discussed for reducing carbon emissions in the sector. One of the prominent options is promoting the use of alternate raw materials by increasing the share of fly ash and slag in cement and parallelly bringing down the use of OPC cement. Push for low carbon cements like LC3, which use calcined clay to replace limestone, is required. Second would be promoting green energy by increasing the thermal substitution rate or TSR by replacing coal in the kiln with refuse derived fuel or RDF and other industrial waste materials. Plants like ACC Wadi and Dalmia Ariyalur have achieved TSR as high as 15 to 30%. Other steps promoting green energy would be increasing waste heat recovery, adopting kiln electrification, and fulfilling electricity requirements through renewable sources. Carbon capture, utilization and storage for cement plants is another option. Global Cement and Concrete Association's 2050 roadmap shows CCUS as the decarbonization lever with the highest potential for the sector for 2050. CSC proposed a 2030 plan for the cement sector's decarbonization. It lays out 3 strategies with quantified targets and the amount of emission reduction the sector can achieve by implementing these strategies. First strategy is limiting OPC production to 10% and increasing the share of blended cements from 73% to 90%. CSC estimates this alone can reduce 43 million tons or 10% of the CO2 emissions as compared to the business as usual scenario. Second is increasing the share of alternate raw materials like fly ash and slag in cement. The permissible limit of fly ash could be increased from 35 to 45%. CSC estimates this would reduce 59 million tons or 14% of the CO2 emissions as compared to the business as usual scenario. Third strategy is to increase the overall thermal substitution rate or TSR to 50%. This would reduce 84 million tons or 20% of the CO2 emissions as compared to the business as usual scenario. Based on this, our estimate is that even as India's production will almost double and will be around 660 million tons by 2030, CSC's proposal estimates an overall reduction of 177 million tons or 42% from the business as usual scenario. This would mean the emissions from the sector will rise only 1.1 times or hardly rise by 2030 compared to 2019-20. To accelerate the decarbonization journey of this sector, first, we need to restrict or control OPC production and increase permissible limit of fly ash in PPC. Clear targets for production of blended cement in the country need to be set. The government needs to come out with notified standards for refuse-derived fuel or RDF to bring clarity. We must define low carbon or green cement and bring in fiscal incentives for green cement. CSC believes that following these recommendations and implementing CSC's proposal for the Indian cement sector would restrict the GHG emissions from the sector from going far beyond the current levels. For further recommendations and more on the decarbonization plan, please refer to CSC's report Decarbonizing India Cement Sector.
For further information, please visit us at www.cscindia.org. And for more engaging content on science and the environment, subscribe to the Down to Earth YouTube channel.